Okay, so in this next video, we're going to turn to page 11 in our course notebooks, and we're going to go through the function family of logarithmic functions. And so notice that we have the parent function as y equals log base b of x, so b is our base, and we have to have that our base is greater than 0 but not 1. And in this particular example, if we look at the table, we can see that they're having us look at the case where of just log of x, and when we don't see a number, we can actually, that's really log base 10 of x. So if you don't see a number, it's base 10. It's just common practice not to write the 10. But so our first step is we're going to use Desmos. Desmos is a great tool that we're going to use a lot in this class. So you can go to desmos.com, click Start Graphing, and it'll take you to this page. And I'm just going to graph log of x. So we can see our graph, put that aside, and notice, right, that if we kind of take a closer look, we have an x-intercept where we touch the x-axis. We have an x-intercept at 1, 0, and so we're going to go back to our notebook page, and Desmos doesn't show it, but we actually have a vertical asymptote at x equals 0, and then we have our graph, and we had this intercept at 1, 0. Remember, this is just a good enough graph. We have the general idea of what a logarithmic function looks like. Now, going over here to these bullet points, this first one that we have is shape. This is whatever you see when you look at the log graph. It's to help you remember what they look like when you're in an exam situation or a quiz. And a lot of people, at least in the past, have said that they see a banana when they look at it. So that's just what I'll write. But it's up to you what you see. So if you don't see a banana, write what you actually do see. Now, looking at the domain, remember domain are going to be the values that we're allowed to plug in, our x values, and notice that we're only plugging in positive values, right? Our graph is only on the right side of the page. So we can't plug in 0 because we have a vertical asymptote there, but we can plug in anything we want up to infinity. And since we can't plug in 0, that's why we used the parentheses. So parentheses means don't include. Right, so I can get super duper close to 0, right? Like I could plug in 1/2 and I'd have an output, something about like right there, right? I could plug in 1/4 and I'd also have an output, but we're never actually going to be able to plug in 0. Looking at our range, these are output values, our y values, and so we can see that our graph is going to go down to infinity, so it goes down forever. So it goes from negative infinity, and it grows slowly, but we can also see that it's going to go up forever. So it goes up to positive infinity. And then we already said that we had x equals 0 as the equation of our asymptote. And so again, this is base 10, but this is actually like the general shape that all logarithmic functions have when the base is greater than 1. When the base is less than 1, it looks like this. We won't talk a lot about that in this class, but I did want you to be able to see that example. So even if it's base 3, right, it has that shape like in the middle graph. If it's base e, right, e is a special number kind of like pi. We'll talk more about it in a bit, but it still has that shape, similar to the one that I drew above. And this last piece is a verbal description. So how would you explain it to another person what that function does? And this one's it doesn't jump out right away, but if we kind of look at the table, we have our x values on the left-hand side, and then on the right-hand side are our outputs. And if we notice, right, that if we take our base, which is 10 is our base, and we raise it to the output, the y value, we get the input, the x value, right? So 10 to the 0 is 1, 10 to the negative 2 is 1 over 100, 10 to the negative 1 is 1 over 10. So the output is the exponent that we're raising our base to get the input. I'll say that again. The output is the exponent we raise the base to in order to get the input. And that's the main idea behind logs. Like, that's the one thing that we really want you to take away from this, is that logarithms are just exponents. They're the exponents that we raise the base to get the inputs. And so in class, on Thursday, y'all are going to work together to finish filling out the rest of these sections, and we'll talk about any questions we might have about the logarithmic family.